Hello there, I'm Chroma, and welcome to part 25 of Making an Abstract Adventure. Welcome back. It has been a really long time since I've made one of these, and a large reason for that has been, between the last episode and this one, apart from being really busy, just running into a huge problem in development with what I was sort of trying to do that I explained in the last episode. So the new gameplay idea that I was trying to go with, just running into a lot of problems with that, trying to plan levels beyond that test level that I made. So the idea that I had, that I still have over here, except this seems kind of, no, it still works, it's probably not functional anymore though, just going from this test level that worked on its own, trying to go beyond that, just running into a lot of problems. But I think now I finally figured out a solution that's not only going to solve problems that I had there, but problems that I think have sort of been present throughout the entirety of this game's development. And it's been a large reason why the game has been changing so much and all that. And I think I'm finally at a point where I'm making real progress again that's actually going to, persist and all that. And yeah, things are going well, which is why I'm finally able to make one of these again. Even though it's been almost over 4 months, but we can just ignore that. So we're going to go into play mode, and I'm going to show this new tweak to the, or addition to the idea that we had before, and then explain sort of how it's working. So I have sort of introduced a tether idea, and actually I'm going to maximize this. So here we have a similar sort of thing to what we had before, where we have the two characters, our cube and our ball character, sphere, circle, whatever, and we still have the idea where we can hit a button and sort of switch between which character that we're controlling, and they're still sort of technically in different environments that'll be able to interact with different objects. With eventually, I'm hoping to bring back the things being transparent in the background and whatnot. But now we have a tether, sort of rope or bungee cord kind of thing that's connecting our two players. And I think this will help a lot of the problems that we were having before. It's going to make designing the levels a lot easier. And more specifically, the reason for that is because looking more at what we were trying to do before with the idea that we had before with the two characters, it was leaning more into a puzzle platformer kind of game, which isn't really the type of game that I'm wanting to make. Puzzle platformers are really hard to design. Puzzle games in general are usually hard to design, so mixing puzzle games with a platformer, it can just be a really hard thing to design, which is why making levels for it was being so difficult, especially when I wasn't intending to necessarily go the puzzle route, even though that's the type of thing that I was making, which I think was just causing a lot of problems and just sort of contradicting things, where I want to do this thing and this thing, but I can't do both, and then that just sort of causing problems with trying to design things. But now that I've sort of been able to realize that's been sort of a problem from the beginning, ever since I had the whole double character idea, which I still want, by the way, because I think that's a unique-ish idea, or a good idea that can help at least just make this game unique. So it's not just a standard 2D platformer kind of thing that there's a million of already, helping my game stand out at least a small bit in that regard. But now with this tether idea, I'm hoping that we can go more in the direction I actually want to go with this game, with it being more of an action adventure-y type platformer. Or at least that's the hope. It'll be a lot easier to sort of go more in that direction now, and it'll be easier to design levels, I think, because I don't have to be planning for two characters at once in the same puzzle manner that I was before. It's not going to be as much about puzzles. There might be minor puzzle elements, but it's not going to be as much as about puzzles as it will be, having cool moments, having cool stuff happen in sort of the adventure-y aspect of it. So with that, let's go into actually explaining more about this, how all this is working here. So we have, a tether, as I've said. So we have an active character and a following character. The characters will switch between different states, between whether they are active or following, and again, pressing a button will switch between which the active player is. And yeah, there's a lot of physics going on, that a lot of stuff that I had to calculate manually just to get it to work exactly the way I wanted it to, and we'll be looking at all that in a minute. But yeah, so that's getting the following player to be following the position of the current active player, as well as still having the stuff going on in the background where certain characters can, or the cube character can go through some platforms that then are solid for the sphere character and vice versa. And yeah, I'm hoping that'll lead to a lot of interesting gameplay mechanics there, including, just being able to sort of pull the other player and stuff like that. So now let's get into how this is actually being done. So over up here, we're actually in a new scene because I still have all of these other test levels that I've made that eventually one day I'll delete, but that will probably be not until we've made... we're close to finishing an actual proper demo. I don't want to delete stuff and then regret it later and hope that, oh, I shouldn't have deleted this thing, I can use it now. But yeah, we'll worry about that kind of later, that sort of organization. But for now, what I've done to sort of test this idea is I just went into a new scene, and all of the code in here is all new, and over in our scripts folder here, yeah, it's all sort of self-contained stuff that a lot of it is copying what we had before. Like all of this movement stuff is, a lot of it's the same for the most part, other than the actual pulling with the whole tether thing. But most of this is the same, just I kind of made it all self-contained so I could focus on this on its own, and if it wasn't going to work out, then I could go back to what we had before easily. But then I'm hoping to sort of integrate this into some of the stuff that we had before when we eventually get to that. It just made it easier to work on. I also still have the dual camera set up, so I'm hoping to eventually kind of bring this back in the way that it was before, where one camera is following the one player, the other camera is following the other player, and then you can see what things this player can interact with and how they're different from one character to the other. But I didn't realize before when I did the dual cameras that there's been more problems to it, particularly with basically just the way I was trying to go about inverting one camera and having the other character not be inverted. So the code that I had doing that before, long story short, there's just some problems with it, especially when it comes to culling, and trying to invert one camera messed with, like, I didn't realize this before, but it just messed with if, like, for example, this sphere is sort of in the ground here, just the kind of order that things get rendered just gets messed up and wonky, and trying to fix that is just a big pain, and I was mainly trying to just get the tether stuff to work. So eventually I'll see what I can do with getting this dual camera functionality back up and running, but for now we're just gonna deal with a single camera for now. But I'm not deleting any of that code, it's still going to exist. And yeah, on that note, in terms of things changing that aren't the tether, I've actually gone ahead and switched to the universal renderer pipeline. And what that means is if I were to go and make a new project, you may or may not be familiar with this, but there are different options here. The usual default ones that you'd select are making a 3D game or 2D game, but there are actually two other options down here having to do with different pipelines, which has to do with how Unity renders things in the back end, more or less. And I've actually gone and switched to this project being done with the universal render pipeline as opposed to the default. I don't remember the name of what the default one is, but it has a name of some kind. So my way of going about doing that is there's a way to just sort of upgrade everything in a Unity file to that universal render pipeline, but I just went and made a new project with the universal render pipeline and then just copied all the assets into this new project. So it's still the same assets, but just, yeah, more stuff going on in the back end that allows me to do some fancy things. More specifically with the biggest reason why I switched over is doing stuff with shaders and being able to do cool stuff like this. So I think it'll help a lot down the road with terms of graphical stuff, allowing the game to look more unique and all that, but it did kind of break some stuff with the dual camera with the stuff that I just mentioned, that I think was still a problem before, but it became more of a problem after doing that switch. But eventually I'll see if I can get that back up and running. It's just not something that's really meant to be done, inverting one camera and not inverting the other. But yeah, it's what I'm going to try and see if I can get working. But with switching over to the universal render pipeline and being able to do more stuff with post-processing as well. If I go over to our camera, actually no, under lighting, still this post-processing thing here, it's still basically the same, not much is, it looks basically the same, just some more saturation for the most part, but I can do a bit more with post-processing now and have more options here that I'm going to fiddle more with later, eventually just, again, getting things to look better graphically. But as well, over here, I now can do, if I can size this up, cool stuff with shaders. So for example, this is one that I made that's controlling this sort of checkerboard pattern here, where when it moves, when it moves along this axis, it sort of changes how the checkerboard pattern kind of is, so that it all matches up if I have a bunch of these copy and pasted around. And I've been doing a lot more between last episode and this episode. A large reason why it took so long for me to make more progress is that I've been doing a lot of learning more about Unity, not necessarily in regards to just this game, but learning more about like post-processing, shading, just more stuff with different aspects of Unity that I hadn't really touched before, and I think that's going to be a big help with you know, designing certain things of this game, mainly in a graphical aspect, but a bit of a coding aspect as well, because I learned some new coding things that I didn't know beforehand that I think will be useful. But alas, so on to the tether, going back to that, I guess now we're going to take a look at all the code that's going into making this new tether system possible. And just a warning, it gets pretty complicated pretty fast, but it's mainly just stuff with manually calculating acceleration, velocity, and positions, and all of that sort of stuff. So I think we're going to start with, actually we'll start with something easier. I'm going to go through all of this code here, but we're just going to start with sort of the easiest one to explain. So the tether camera follow is kind of the same as it was before, where it's just following the player, and I think this looks exactly the same as the other camera follow script that I had before, just sort of, again, making it its own self-contained thing, and also having this go back to the functionality that there was before, where it switches, when you switch characters, it'll switch which one it's following, as opposed to the dual camera just following one player at all times. But eventually this will hopefully switch back to the dual camera system. And then, Tether Switch, I believe looks exactly the same as our normal player switch, just everything here has a tether, the word tether in front of it, just because, again, keeping things sort of self-contained. So we have our two characters here, and then when you hit, it's still the left mouse button. No, it's the right mouse button now. Is it? Yeah, when you hit, yeah, one is the right mouse button. Yes, so when you hit the right mouse button, then it switches which character is active from the cube character to the sphere character. And then the last thing before we get to the monster, that is the player move script. The tether line has to do with the actual line that we have here. So going over here, we actually have the tether being a parent game object, and then the cube and the sphere being child game objects. Now the tether itself has this tether line script that's both getting a reference to the cube and the sphere, and it's going and actually drawing this line here with the use of a line renderer. And it has functionality that the further apart these two characters are, the thinner the line gets. So that's just some kind of artistic flair there, but I'm hoping eventually to make the line look better. I'm hoping forward to, like, story-wise, even though I'm not going to be getting to that for a while, it's not just going to be like a physical rope or, you know, bungee cord or something like that. It's going to be, I don't know, something arbitrary and magical or whatever, like something like Dark Force that's like making them sort of stuck together, something like that. But that doesn't really matter right now. That's more story fluff that I'll be coming up with later. But back to code. So over now, yeah, so this is how all the line render stuff is being done. It's pretty simple enough there. Now, over onto the player move. A lot of everything other than the tether pulling is all stuff that's sort of copied from different coding stuff that we've made before, mainly the player move, the player jump, and the player ground detection. Just putting it all in one script for now, as I was just trying to get it all to work, and eventually I'll probably, well, as I integrate this stuff back into what we had before, I'll probably sort of split things up and put them back in their own scripts so that they're not as long. Although I will say that having some of these things in the same script made it a lot easier to code things as some of these sort of interacted with each other, as opposed to getting a bunch of references to different scripts. So that did make some things easier to kind of comprehend while I was programming some of this more complicated stuff. But I think it'll still be better in the long run, organization-wise, to go and kind of separate some of these functionalities out into their own scripts. But I'll, yeah, be getting to that eventually after the tether system's all up and ready to go, because I still do want to add a few more abilities to it that I'll be getting to after showing all this code here. So, getting into all that, there's no easy way to go through explaining all this. I just kind of have to go through from top to bottom. So, yeah, so we have our move code, jump code, and ground detection. That's all the same. And a lot of these variables, I think, should be basically the same as was in the other code, except something new, a jump input store time that has to do with, actually, yeah, back into Unity, showing off. So before with our jumping, we had a functionality where when you go off a platformer, yeah, when you go off a platform, you have still like a split second before like being able to jump, just nice platforming mechanics there. We have now another functionality where if you hit the jump button right before you hit the ground, it sort of stores that input and you're able to jump if you hit the space button even like a second before the ground. And that's just, yeah, making these a little easier, a little more user-friendly, and that sort of stuff is just kind of things that exist in good platformers that I wanted to implement here, and it wasn't too difficult to actually implement. So yeah, then onto the tether following and active pulling. There's quite a lot of variables here because it was just a very complicated thing trying to set this up. And I went through just a bunch of ideas just of how I was going to go about doing this, because there was not a lot of reference on this kind of idea. There is very few games that have this kind of mechanic, which is both a good thing and a bad thing. It's good because it's unique-ish, hopefully, but it's bad because it's hard to find reference to how to do this stuff. But yeah, so we have an awake function where we get all the references there. That should be kind of the same. I get a reference to a past position. That's something I was doing before. I don't think I need that anymore. Let's delete it and see if there's errors. Is there? Yes, okay. So I think that was the remnants of something I was doing before. I don't actually remember how important that is. But anyways, so most of how a lot of this calculating of all these forces is done is I changed it up from, instead of having multiple add force calls like I had in my different scripts, I've combined all of those like rigid body add force or velocity change calls just into one vector 3 called combined velocity. And as we go through all this stuff, calculating our move forces and our jump forces and all that sort of stuff, and our falling and all that, we're just saving all of that in this one variable, a combined velocity that is a vector 3. And then at the end of all of this stuff, we are first just setting the z value of it to 0, just make sure we're not moving in that non-2D direction, just make sure our players are where we want them to be. We are then going and just having one rigid body dot velocity equaling the combined velocity. So this is allowing us to have, one, a lot more control over the exact velocity, rather than using rigid body to add force and the force mode dot impulse, which is effectively doing kind of the same thing. We were able to just have more control over the exact speed that our players are moving and falling and jumping and all of that sort of stuff. So with calculating this combined velocity, we are, I guess if I'm just going top down, we are getting a direction velocity, or a vector 3 that is getting the other player move, the one that is not this script. So if we're on the cube, it's getting the circle's position and vice versa, getting that position, subtracting our position, and that's getting a direction vector there that we're then using when we're calculating that following force. Now, if we are the active player, then we're going to be running this code. If we're not, then we're going to be running this code down here. Now, if we're the active player, we're going to be taking our current position and sort of storing it for the other player to follow, because it just kind of looked a bit nicer to, rather than having for example, the sphere character following the cube's exact position, having to be a slight delay. So it's following like the cube's position at like 0.05 seconds in the past, and it just kind of looked a bit nicer in terms of sort of how it was following. Then we are storing our past position as what our... Oh, no, yeah. So we're storing our past position as what our current rigid body velocity is. Then we are... Because this has to do with this coroutine, as we'll see below. Then we have getting our input. That's going to be for our moving and our jumping and all that, which going down to that actual function somewhere down here. Wherever that is, if I can find it. Without... Okay, if I could find it, it is down here. There we are. So with getting all of our inputs, I've stored that sort of in their own scripts here, just so that they can be all self-contained, and then just having all of our inputs in one place, just so it's easier to see. So we have get key input, that's our moving left and moving right with the A and D keys. Getting key down input is getting this down input, and then getting key up input here. And I made these 3 separate functions because some of these are being called in fixed update and some of them are being called in just normal update, so that's why they are separate there. Up here though, getting key input is just getting that move input, and with that we are then calling this move function that is basically identical to what we had before of just... Actually, I'm pretty sure it's identical. Let me double check, because again, it's been months since that last video and I don't know the exact state of what all this code looked like back then, other than this all this tether stuff is new. So this is our move code of just getting our input, and if we are moving right, then we set move dir to be going to the right times our move speed and all that, and otherwise if it's to the left, then we're going to the left, and then stuff here that when we turn around we sort of go in the other direction just a little bit faster, and then if we're not moving at all, then it goes towards 0. Then at the end we multiply by our move speed, and then we just return that velocity to be added to our combined velocity. Next, we calculate our jump related stuff, and rather than this being just a function that will do an add force call, it's going to, if we are jumping, it's going to sort of return the y velocity of our jump to then be put into the combined velocity there. So that down here, jumping. There we are. So here we're setting a jump velocity to 0, which is a default value. Then if we can jump, and can jump is based on our ground detection, and then jump input is going to be whether we're pressing the jump button and it's being stored or whatnot. Then we are setting a jump velocity to the jump force times 10, just being a large value to launch us in the y direction really fast. And then we were setting a bunch of values to like false and true that have to do with that. So can jump is false, jump input is false, and is grounded is false because we're leaving the ground and we've just jumped and all that. And then jump held is true. Yeah, and we'll see how this is used in just a second. Then we are returning that jump velocity back to here to then set our y velocity to that so that we can jump. Now, next, this stuff, yeah, this section of code is then for our falling. Eventually, I'll probably comment all of this. Just, it was all me writing a lot of things and going back and forth and deleting things and writing other things as I was just trying to get all this to work. But eventually, I'll probably comment this and make it all nicer so it's easier to see, because this is quite monstrous and just probably very complicated to look at. So next, we have our falling code here, and this is testing if we're not grounded, which is the exact equivalent of our fall detection, or our ground detection code of testing if we're on the ground or not. And we're using gravity, so if you decided to disable the rigid body's gravity, it's just going to disable all of the gravity in case we wanted to do that for some reason. And then so if our current combined y velocity is equal to 0, so basically if we didn't get anything from the jump, then we fall, because if we have that y velocity set to go up really fast, we're just going to not fall for a frame. Then we are getting this fall velocity here, which down here, well, is right here. This, again, should look pretty identical to what we had before. So we have a fall velocity that we're setting to our current y velocity, and then we're just going to keep sort of subtracting based on our gravity multiplier and a certain other variables based on jumping related stuff, pretty much. So here we have if our y velocity is greater than 0, and this is where our jump held variable gets used. So if we're going up and we're not just holding the jump button, then we have a low jump multiplier that's allowing us to, when we let go of the jump button, we start to fall faster, basically, to be able to have that sort of low jump. Then our if our rigid body velocity is less than 0, so we're falling, then just having a fall multiplier. So then we just start to fall even faster, so it just makes a nicer looking jump. And then our y velocity here, we are then just also adding a terminal velocity, basically making sure that we can only fall a certain speed, just so we can kind of cap that at a certain point that we feel like. And yeah, with that, then we return that fall speed, which back up here, then gets used. So that then gives us a combined velocity that's, or then what we want to take off of our our current velocity in order to fall for this frame. So now all of this stuff is then going to be all of our pull active code. And I think I'm going to get back to that in just a second, because there's a few things I want to look at first. Because this is a bit more complicated. I kind of want to look at the following code first before the active pull code. So then otherwise, if we are not the active player and we are the following player, as well, just a check that time.delta time is not equal to 0. And I think that doesn't need to be there anymore. No, yes, it does, because there's a case here where we divide by time.delta time. So just making sure that time.delta time is not equal to 0, so we're not dividing by 0. Yeah, we don't want to. And this shouldn't be a problem anyway, because all this is being done through like physics and velocity, and that's not going to be set when time.delta time is equal to 0. So yeah, so when we are falling, then we want to first just test if our past position is equal to, or no, if past position is equal to rigid body dot position, and this past position is actually going to be the past position of the other player. So with what I said before about having a coroutine that's sort of saving our past position so that our following player is following where the active player was like a second in the past, that's getting this past position, which I suppose for clarity I could rename to other past position, but I can do that later. So we're getting this, if our past position that we're trying to follow is equal to our current position, so if we're on top of it, then we're just making sure that this current acceleration, we're setting that to 0, because we don't need to do any following. That's basically allowing us to, if we are exactly where the other player is, then we're not following. Then we're like just making sure the current acceleration is 0. Then, otherwise, if we are not where the past position is, so we need to follow it, then we start doing our follow code, basically. So first we just have a test that if our direction, which was up here, we're calculating, the direction, or basically the distance between the other player and us, if it's less than a certain value, then we're just setting the dir to 0, so we're not following the player at all. So basically, if we are close enough, it's also going to be set to 0, which, yeah, but then this is slightly different than this, so they have two different checks there. And this is just making it so that if the players are too close, there's just not any following going on, because otherwise it was a bit jittery, and this just removes some of that jitter. So otherwise, if we're far enough, then we are actually changing our direction. So down here, we're going to be setting a current acceleration to the direction of the player, or the other player, the active player that we're following, times a follow acceleration. But just to get that, so to get it so that the further that we are from the active player, the more we are following them. Currently, it's going to be linear, basically. So a linear amount of acceleration increase for how far we are from the active player. By passing in this function and going the mathf.power, so 2 in the direction.magnitude, and then multiplying it by the normalized direction again, this is basically turning it from being a linear increase to a quadratic increase. So basically, the further we get from the active player, it's going to increase the amount that we're getting pulled towards the player even faster, which this just made it look better for the further we get, the more there is a pull, basically. So then after that, then we are setting the current direction to that with a little bit of follow smoothing, and then making sure that the Z direction is always 0. It never shouldn't be, but just having a few checks in here just to make sure those Z values are always 0, so we're not moving in something that isn't the Z direction, or so that we aren't moving in the Z direction, just to be absolutely sure that isn't happening, because that'll very easily, very quickly sort of break the game if that happens. So then, after all of this follow code, we are then setting the combined velocity to the current acceleration times time.delta time plus rigid body dot velocity. And this is basic physics of how to how the acceleration kind of should be added to the combined velocity the way that we want it to. Just sort of, if you're familiar with any sort of physics, just taking acceleration equation, basically taking the acceleration equation of acceleration equals velocity 2 minus velocity 1 divided by time, or the change in time, and then rearranging that to, we're trying to set that second velocity, basically. So yeah, but if you're not familiar with that, that's fine. This is basically just what we do here to add this acceleration with the current velocity to our, or with this would be the velocity of the last frame, and then to our combined velocity that we want to set. Cool. So after doing that, we then have a few more things that we're doing here. So if we are using gravity, we are sort of having a, actually, yeah, so up here, what I didn't say is that this is the falling that's happening if we're the active player. There's a different type of falling if we're the following player, just sort of treating the following just a little bit different. The falling just a bit different. So then we're calling that function, which going down here is right here. And this could probably be after the fall function, but the order of these don't really matter because I'll be separating them eventually anyways. So we then, this function is pretty much very similar to this, just some of these other things are removed, having to do with the jumping, just make sure they don't happen, basically. So we are setting fall velocity equal to the gravity multiplier plus the fall multiplier, because we're just always going to have that fall multiplier in place. And then we are seeing if the rigid body velocity is less than negative the max follow speed, then we are setting it to that max follow speed. Again, just making sure that we aren't following more than we should be. So it's the exact same thing as this terminal velocity, but just I set them as different things just in case they need to be different values for the following player. So next, over here, then we are enacting drag. So a follow drag that's different from the drag that's happening on the other player through the move function. So we're just setting a different type of drag that's just going combined velocity divide equals 1 plus the follow drag. And yeah, by having making sure that follow drag is greater than 0, we're then making sure we're not going to be dividing by a 0. Technically, this only matters if it's -1, but we don't really need it. We should never have a negative follow drag anyway, so this helps for that. Lastly, after doing all of that and calculating all of our combined velocity of what it should be, we're then just having one final test just to make sure that it's not greater than a be-all, end-all max follow speed. And then if it is, then we are setting it to exactly that max follow speed, and then just setting the current acceleration to match whatever that would need to be. So this is just more physics stuff of just, actually this is the exact thing I said before. Acceleration equals v2 minus v1 divided by time. And that's just making sure that even though so we've hit the maximum follow speed, just setting the current velocity, the current acceleration to not be still greater than what's making us go beyond that max follow speed. Fair enough. All right, so then after all of that, we are then calling a turn function. That's pretty simple. That's just making our character, mainly the cube character, just turn as it goes left and right there. And then it's actually not doing anything on the ball character because rotation smoothing, I think, is set to 0. Yeah, for the ball character. And then again, one last time, setting the Z to 0 and then setting the velocity to that combined velocity. So that's how all of that basically is being done. But then one thing I skipped and said I was going to be coming back to is then the pulling code for the active player, which is pretty much the same. Well, it's similar, but we'll go through it. So starting here, we are, rather than the active player being pulled at all times, we are testing that if the following player gets a certain distance, which I think currently this is set to 5 units, if they get a certain distance away from the following player, which would usually, it's not going to usually happen if you're just doing normal platforming. It's going to happen if the following player sort of gets snagged on something. So if we intentionally want the following player to get like hit on a wall on their side, but then the active player can keep going, then when the active player gets so far away, then they start getting pulled back, basically. And then, so if this happens, then we are first setting the direction. Again, we're sort of scaling it by a different amount, basically, except this is exponential. No, wait, hold on. Sorry, no, actually, I forget the order of this. Yeah, it's f raised to the power p. So this is the opposite of what I said. Yeah, so this one is the quadratic one, and this one's going up exponentially. So I guess I can quickly go and draw what those functions look like if I just open up Paint here. So the one for the active player, rather than being linear, is going to look something more like this. And then the quadratic one is also going to look like this. But the exponential, okay, I can't really draw these right, but it's fine. You get the picture. They're both basically going up faster the further they get away, but the exponential one goes up even faster. So one looks like that, one looks like that, kind of. It's close enough. Anyways, it basically just making the following look better by the further they get away, the more they are trying to pull towards each other. So that's what that's doing. And then otherwise, so if the active player is close enough, then they're just setting the gear to 0 so that we're not doing any of that following. And then that's basically it there. Then the rest of the active player stuff is being calculated through the move and the jumping. So then we are just, again, having a little bit of smoothing just to remove just a little bit of jitter if that was happening. Just moving towards having our current active pull acceleration just being set towards whatever it needs to be, but just slowly smoothing towards it. Then again, setting the Z value of it to 0 as just making sure that nothing's going to go wrong there, and then setting the combined velocity to that value. And with all of that, that basically should cover most of this code. No, it doesn't. Actually, there's a few other things here, right? We have a whole update function here that's mainly dealing with the jumping, and there's some more code that we can go through here because the jumping is a little different now, I suppose. So in this update function, we're then seeing if we're the active player and only if we're the active player, because the following player doesn't jump, then we are getting both of these inputs for whether we are holding the jump button down and jump button up, which could be in the same function, but I'm leaving them separate for now for if we add more inputs to it. Then over here, then if jump down is true, then we are setting jump input to true, and then we're actually storing that jump input, and then we're calling stop coroutine and then start coroutine just to make sure it's only running. There's only one instance of it running, unlike with the past position where we want that to basically be happening every frame. Then if we've just let go of the jump button, then we're setting jump held equal to false. And this is helping with the falling function, where if we want that low jump thing to happen, that's only happening after we've jumped. So if we are falling and jump held is false and we start holding the jump button, we shouldn't start falling slower or anything like that. Like none of that jump functionality should be happening after we've jumped and let go of the jump button. So with all of that, our stored jump input down over here is then just waiting some amount of time, the jump store time, and then it's setting jump input to false. So that's then going to make it so that if we hit the jump button, then this jump input is true and it's being stored. Then if we hit the ground like a second after or before this runs up, then we still get to jump the second that we hit the ground. Then we have some on collision enter, on collision exit stuff. It's basically just our ground detection, the same way that it is before. With this stuff here, testing that it's grounded, not wall, basically. Same thing here. And that's testing setting is grounded to true and then can jump to false. And then when we leave the ground, rather than setting can jump to false right away, we are having a coroutine that's just, again, saving that jump input and then making sure that we aren't still on the ground. So in case let's say that this was set to like 0.5 seconds, if we leave the ground and then touch the ground again within that 0.5 seconds, making sure that this doesn't get set to false, which it shouldn't. So yeah, after doing that, actually, I suppose I could also just put this up, the stop coroutine up there, just to not cancel the jump, but that shouldn't matter because it still works as is. So then after doing that, we can then set the can jump value to false after a few seconds, or like half a second after we've left the ground. And then finally we have this follow past position, which is just waiting a second and then setting past position to the store position, just so that the following player is following a delayed position of where the active player is. So with all of that, that is all of how this tether is working. So if I go back into play mode, after the small changes that I made, just compile real quick. So with all of that, this is how all of this tether functionality is working. And I'm really happy with how it's turned out. It was really complicated just to get all this to work the way I wanted it to. Again, especially because there was just very little things to find in terms of reference of how to get this to work. If you know any games that have a tether mechanic like this, I'd love to know, just to sort of be able to get me inspiration. I know a game that came out in 1990 something, Knuckles Chaotix, has kind of a tether system, but I looked more into it and it operates very differently from how I want this to function. But it still kind of helped. Yeah. So with all of this, we have the following player following the active player, and it follows quite nicely. And then we can have this player sort of get like dipped off edges a bit and stuff like that. We can switch into the other character and sort of have the once was active player get turned into the following player and all that sort of stuff as well. If I go and activate some of these round platforms, if I go and actually put something in between these two players here, then we also get the functionality of, so this is something that only the sphere character hits as a wall. So if the active player gets far enough, then the active player sort of gets pulled. I wanted to make sure that the active player wasn't getting pulled that much unless it kind of needs to happen when they're getting way too far apart. Because I noticed that it just didn't really feel good to have, like if you're jumping and then you're sort of getting pulled too much by the falling player, it just, yeah, from a controls and gameplay feel perspective, it doesn't feel good to be like not able to jump as high because you're being pulled. Now, there's some cases where I might want that to be the case, like this, and when the if the ball character is like underneath the platform and you know you get pulled a little bit. But if it was happening like every time you're trying to jump when the ball character is right there, then it just does not feel good from a gameplay perspective. But here it is fine because it kind of needs to happen as well. With that active pull, I can have stuff like this. So I have an area here where there is, you can't really see it, but there's none of this blue platform here, so the ball character actually falls through. If I switch to the ball character now, we kind of fall. And this could lead to some interesting gameplay thing maybe. Yeah, so I have some ideas of how the sort of level stuff I can do with this, but it's something I'm going to play around with a bit more. But I definitely think I have a lot of ideas. I have more ideas that I think will work a lot better than what I was trying to do before when these two characters were different. Because now it'll be a lot easier to sort of plan around this, and I can plan a more linear level that's not so puzzly, where you're sort of going along and maybe having to like jump and then mid-air turn to the other character. I want to test how well that works. And I just feel like there's a lot of interesting things that I can do with this. Now, in terms of the characters, well, there's also still a few more little things to sort of iron out with this. Something I would like to do is, if I do this again, I want to try and seeing if I can set up a system where if the active character is sort of getting pulled and you let go, or you hit the other direction, you'd sort of get like launched in this direction, and maybe that could be good for like a boost of speed somehow. Maybe that can help you make a jump. So you do this, you let go, you go flying this way, and then make a jump or something like that. So that's like something small I'd like to set up, but then there's a few more things beyond that. So you'll also notice that some of the abilities that we had before aren't here right now, and that's because eventually I kind of want to integrate some of them in. But now I kind of want to do more with this tether mechanic and have more of the gameplay center around it, and have some abilities actually more directly use this tether mechanic. And how I want to go about that, or some abilities that I've thought of, use some of the things that we've made before, so they hopefully won't take that long to program in terms of hoping that there's no problems that then come up with the tether itself. So I want to set up basically a launch horizontal and a launch vertical. So I want the cube character to have an ability where, actually the exact ability that it had before, where it can like launch through the air, and then the ball character sort of might get launched further, perhaps, depending on how the tether physics work with that, if the cube gets like a massive burst of speed in a horizontal direction. So I want to bring back that, of the cube character being able to launch forward, and then I want the ball character to be able to launch into the ground, like that smash ability, but then I want it to be able to bounce. So basically, if you need to go somewhere up high, being able to like hit a button, you smash into the ground and sort of bounce up, getting more of that ball bouncing kind of functionality, as well as still having the slam of being able to the cube character bashing through stuff and breaking certain destructibles, and then the ball character smashing through ground and maybe smashing through stuff in the air too as it goes up. I haven't decided on that. That just came to mind as I said that sentence, but we'll see how more of that stuff is able to get used as well. So before I had it so that the ball character could double jump and the cube character could wall jump, that was just very unbalanced. The double jump was just way better than the wall jump was, and I'm trying to have these characters be as mostly 50-50 balanced, so that you're more likely to be both of them most of the time, and one isn't clearly superior than the other. That's the hope that I'm trying to have. So in terms of designing abilities, I'm trying to sort of design them in sets of two, where I design an ability for the cube and then something for the sphere that are sort of either opposites or like close, or just that are balanced within each other, and then I design two other abilities, stuff like that. Again, I don't want to design too many things because then we're getting pretty feature heavy, which is I don't want things to be bloated that much. But I do want a few things just to utilize more of this tether mechanic and be able to sort of ideally have like one character be able to launch and then use that launching, pulling force to do some interesting level mechanic stuff with that. So I'm going to have a launch forward and then a launch like down and up. I also want to try having, what I'm going to see if it'll work, is having the cube character being able to sort of freeze in place almost. So like you're in the air and you basically freeze, and then I want the cube character to almost grow a little bit, maybe twice the size, and then the sphere character to be able to use the frozen cube character as a platform, basically. So having the cube character freeze midair and become a platform, then the ball character can jump on. Maybe. I'm going to see if I can get that to work. I'm not 100% sure on that yet. And then the contrasting ability for that is then I want the sphere character to then have a glide of some kind. So that might that might allow some of this to happen, maybe if the you have one character gliding and the other character is like hanging below. Just seeing what sort of stuff I can do with that, and if that will work effectively. And yeah, for the most part, that I'll see if I can come up with more things, but again, I don't want to be too feature heavy. I want to make sure things are going to work. But that is the sort of itinerary of where I'm going from here. And then I wanted to design a better test level here to sort of make use of all those abilities and test more of the sort of action-y side of things, of testing, sort of switching between the characters pretty often as you're going through platforms and all that. And then I want to bring back more of the sort of transparentness of seeing the other characters, what they can interact with in the background, and seeing if I can get that to work with a dual camera, but I'm not fully sure on that. That stuff I'm just going to have to figure out. But I'm happy that I finally at least got the tether system working, because that was just a nightmare to just get to work. I was going between a whole bunch of different ideas of how exactly I could go about doing that. But yeah, that basically brings us to where we are now, and that brings us to the end of this video. So yeah, with all of that, I know now sort of where I'm going from here, I hope, and I'm confident that I'm not going to be undoing progress again. So with the last few videos, there's been a lot of, haha, I've done this thing, but now I had to undo it because it wasn't working, and now I'm doing something else. But with this tether idea, I think that finally solves a lot of what was causing that to happen. And between then and now, I've done a lot of planning, and I don't remember whether I mentioned this in the last episode, but a lot of the story I have all the story basically planned in a general sense, and I have like the levels kind of planned. I have a lot of things planned, but then it was sort of going from that planning to actually making stuff. That was just causing a problem, specifically with the whole puzzle kind of problem that there was before. Starting to make levels and then realizing, oh, this thing I planned isn't going to work like how I thought it would. But I think I finally sort of solved most of that now, and this whole tether idea will still very much work with a lot of the story that I had planned before. And I have a several page Google Docs document that I don't think I've shown the most recent version of, but long story short, we have a plan now and we know where we're going with it. And hopefully this will be the last time, I don't want to jinx it, but this will be the last time that I'm having to scrap a lot of sort of functionality, I hope. Now, eventually I will be cleaning a lot of this stuff up when we get more to actually finishing a proper demo, and the demo plans are still basically the same, where I want to make 3 mini levels that may or may not be in the final game, but at the very least they'll use a lot of art assets and stuff that'll be in the final game, that just sort of test different ideas, with one being kind of easy, one being medium, and one being harder. Pretty much. And then they'll take place, yeah, in sort of 3 different environments to practice making art for what will eventually be 3 different levels and all of that sort of stuff. So that is the plans for where we are going from here. But yeah, I think that will do it for this game development log. So thank you all so much for watching, and as always, I'll see you around.